Hey guys, I just wanted to kind of jump on here and go through this gizmo with you if you had some questions on how to do it or if you were struggling. So let me kind of guide you through this. The first thing that I would do is I would split screen if you are working online on a digital copy. As you can see, I've split screened this and I have my document on one side and I have the gizmo on the other side. And then you can always maximize it if you need to see it bigger, or you could stretch it out. But that's the way that I would do that. If you're working on paper, then you don't need to split screen it. Just have your gizmo open, or you could just watch this video. Okay, starting with the prior knowledge question. Read through what the question is. We're asking what would be bigger, a football or a volleyball, and how would we measure and compare the sizes of these two balls? We would measure the blank of the football and volleyball. So what have we been measuring in this last week? And that's how you would fill that out. Then you would launch the gizmo. So I have launched it, and I'll kind of go through all the things that you do here based on what it says. First, it says that to begin, we're going to remove the 50 milliliter graduated cylinder from the cabinet. We're going to put it under the faucet. So let me get rid of everything that I don't need. And this is the 50 milliliter one. Nope, that's the 25. So we'll pull out the 50. There we go. And place it under the sink. Then it says to fill the cylinder about halfway as shown. So I'm going to turn on the sink. And since it's 50 milliliters, I know I've got to go out to about 25. Whoop, a little bit more. There we go. And try to get just a tad more. Doesn't have to be perfect. Good enough. Okay. Then what volume is represented by each small tick mark? The tick marks are the little increments or lines. We've kind of looked at those when we went into the lab. And how is each measured? Well, if I start at 20 and I need to get up to 30, I'm going to count how many tick marks there are. And I'm going to start by counting by ones and see if that I can make it up to 30. So starting at 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So by counting by ones, I do make it up to 30. So each tick mark is 1 milliliter. What's the shape of the water line? So I'm going to take the magnifier and place it there. And I can see that the shape of the water line, if I look at it really closely, is curved. Okay? And that is called the meniscus. And we always read it at the bottom of the meniscus. What is the volume of the water in this graduated cylinder? And I'm reading this at the bottom, 21, 22, 23, 24, 25. 25 milliliters. Okay. Now it says for activity A that we're going to drag all objects to the cabinet. And now I'm going to move the 25 milliliter graduated cylinder, the 250 milliliter beaker, and the 2 milliliter pipette to the counter. So I'm taking everything back. I want the 25 milliliter beaker, or graduated cylinder, and the beaker. So that's a beaker. Place the 250, fill a graduated cylinder with a given amount of water. That's my goal. And I'm going to use the beaker to do that. So place the 250 milliliter beaker below the faucet and fill it with water. Move the faucet handle up to pour faster. You will use the beaker as a source of water in your experiments. So I'm going to fill it up. Okay. Then I'm going to pour water from the beaker to the graduated cylinder. I'm going to move the beaker over the graduated cylinder. Add about 15 milliliters of water to the graduated cylinder. Does not have to be exact. Oh, wow. So it doesn't have to be exact, but I do need to be somewhat closer than this. So with a little bit at a time. There we go. Not bad. Okay. I think that's good enough. How many medium tick marks lie between the two labeled tick marks? Well, I'm looking at the big tick marks are, this one says 15 and this one says 20. And the medium tick marks are just a little bit longer than these shorter ones. And how many increments or how many milliliters do they measure? If I count by one, do I get up to 20? So 15 here, 16, 17, 18, 19, and then 20. So each of the medium tick marks here measure one. I'm not sure what I just did there. There we go. Okay, one. Okay, how much? Oh, how many are there? Whoops. How many medium tick marks? Sorry. 1, 2, 3, 4. There are 4, and they measure 1 milliliter. Okay. How much volume does each small tick mark represent? Well, if each medium one represents 1, then the smaller ones have to be half of 1. So I'm going to represent that by 0.5. Each little tick mark cannot represent 1 because that would be too many. The medium ones represent 1, so the little small ones have to represent half. Estimate the water volume in the graduated cylinder to the nearest 0.1 milliliter. Remember to read from the bottom. So I'm going to take this magnifying glass. There we go. I came pretty close to 15 milliliters when I filled it out. So the closest tick mark or increment line that the water measures at, it's closest to the 15 milliliters. So I'm going to say 15 milliliters. Okay, now scientists use pipettes, also known as eyedroppers, to add or remove small amounts of water. To fill the pipette, place its tip in the beaker of water and click the bulb once. To release a small amount of water, place the pipette above the graduated cylinder and click the bulb. Do this until the graduated cylinder contains exactly 17.5 milliliters of water. Remember to read the volume at the bottom of the meniscus. So I'm going to take this out, place it into the beaker, and I'm going to fill it. I'm going to take the graduated or the pipette out, and now I'm going to squeeze it to get to 17.5. So remember, each medium tick mark was 1. So that's 16, 16.5, 17, I think I got 17.5. Okay, so 16, 17, yep, 17.5. I think I did pretty good there. What do you think? All right, now it says to take a screenshot. So I'm going to take Tools, Screenshot, the little camera, and you can see it took a picture. Right click image or copy to download. So I'm going to copy it, and now I'm going to put it into my document. I don't need it that big, so I'm going to drag it to get it so it fits. There, pretty good. Okay, now it says to use the gizmo to complete each of the following challenges. When you have finished each one, take a screenshot and add it to the chart. Label each image with the volume. So for letter A, you're going to fill the 25 milliliter graduated cylinder with 11.5 milliliters of water. So what you'll want to do, we'll get rid of this image, get rid of this. Oh, we might want to keep that, but I can move it down here for now. You're going to need to take this back into the beaker. Fill it back up with water. Before you do that, you want to pour out some of the water. Maybe you can pour out all of the water because you've got to fill it up with 11.5 milliliters of water, and you are at 17. So I would keep emptying it. Okay, now we're below, we're about 10 actually. So now I would take the pipette and drag it over. I would move this over and I would keep adding water. 10.5, 11, and 11.5. I would use my tools to take a screenshot. I would copy that. I would add it, and then I would paste it, and then make it smaller. Okay, so just keep doing that. All right, this one says to take the 100 milliliter graduated cylinder. So you're going to want to put this one back. So empty it. Actually, just put it back, and I think it empties it. Yep. So then bring the 100 one over. And then follow the same procedure as you did with the 25 milliliter. So the 100 milliliter graduated cylinder, fill with 76 milliliters of water, and then you'll drag it back and grab the 50 milliliter one. Okay? So I won't take time in this video to do that, but you do know how to do that now that I've given you the instructions. All right, number 6, suppose you needed to measure exactly 15 milliliters of water for an experiment. Which graduated cylinder would be the best one to use and why? Would it be the 25, the 50, or the 100? So activity B, and this is just free exploration for regular solids. You'll return all items back to the cabinet. Okay. Return, so we did that. Drag the block and the ruler to the counter. Ruler, block. You'll need a calculator. The goal is to measure and calculate the volume of a rectangular prism. Count the squares in the rectangle at right to find its area. Well, it's given 4 centimeters, 1, 2, 3, 4, by 2 centimeters, 1, 2. So 2 times 4, we know that area, we're measuring the area using 2 dimensions. And we do that by multiplying 2 times 4. So 2 times 4 is 8. So the area of the rectangular prism is 8 centimeters squared. How does the area of the rectangle relate to the lengths of each side? So go ahead and try to answer that question. Okay, so since we multiplied the 2 dimensions, the area of the rectangle relates to each of those dimensions. So multiplying the area of the rectangle relates to the lengths of each side by multiplying 2 dimensions. Okay, so now let's look at this rectangular prism. A rectangular prism has 6 rectangular faces. Look at the block shown below. Each cube inside the block has a 1 centimeter side and a volume of 1 cubic centimeter or 1 milliliter. So here we can see we have blocks, kind of looks like a Rubik's Cube. So what are the length, width, and height of the block? Well, the length measures out 3 cubes. The width measures out 3 cubes. And the height measures out 1, 2, 3, 4 cubes. Okay, so multiply these 3 dimensions. What is the product of the length, width, and height? 3 times 3 times 4 is 36 cubic centimeters. And how many cubic centimeters are in the block? 36. Okay, so just as the area of a rectangle is the product of its length and width, product meaning multiplication, the volume of a rectangular prism is equal to the product of its length, width, and height. So in the gizmo, place the ruler over the block. Okay, and it gives you the measurements. Its length is 4.18 centimeters. Its width is 2.67 centimeters. And its height is 7.63 centimeters. What's the volume of the block? So remember, we are doing length times width times height. So the volume of the block is 86.2 centimeters cubed. Remember, it's cubed because we have 3 dimensions. Okay, so now activity C, for your exploration, you are going to return all of the objects back to the cabinet, and we are going to use water displacement to find the volume of a large sphere. Okay, so have you ever climbed into a tub and seen the water rise? The amount of the water rises is related to your size. The bigger you are, the more the water will rise. This method, called water displacement, can be used to measure volume. So we'll find the volume of an object using the graduated cylinder. And this technique works if the object you're measuring is small enough to fit into the graduated cylinder. So take out the 100 milliliter graduated cylinder and the pipette. Fill the 100 milliliter graduated cylinder to exactly 40 milliliters using the beaker and the pipette. Actually, I'm going to pop this down, but I don't know if I'm going to need it, so I'm going to just fill this up. All right, I think I did pretty good. Drag the rock into the 100 milliliter graduated cylinder using the magnifier to read the new volume. All right. Is that what they want? They want take out the 100 milliliters. Whoops. It says 40. I only needed to measure to 40. Okay. We'll start over. Sorry. All right. There we go. 40. I was wondering because I thought, well, that's probably going to overflow. All right. So I'm going to take the pipette. And I do need to get some water and use the pipette to add water to get close to 40. All right. There we go. Okay, so I think that's good. 40 milliliters. Now it says to drag the rock. Let's move the pipette. Drag the rock and pop it in. Oh, okay. Now we see that the water has risen. I'm looking at the increments, and I need to go from 40 to 50. And so what are they measuring by? If I count by ones, am I going to get to 50? 41, 42, 43, 44, 45. I am not. Let's count by twos. 42, 44, 46, 48, 50. I do get up to 50 if I count by twos. So each increment is 2. Okay, what is the current water volume in the graduated cylinder? I would say it is closest to the 48 mark. It's kind of in between, but I'm going to say that that's close enough to 48. Okay, since it started at 40 and it rose up to 48, we know that the difference between 40 and 48 is the volume of the rock. So the difference between 40 and 48, take 48, minus out 40, subtract 40, and we're left with 8 milliliters. Since it's a rock, a solid object, we know that that needs to be cubic centimeters. Okay, well, it went up. How much did the water volume change? So honestly, that's really just 8. So then letter C, based on your answers to A and B, the volume of the rock is 8 milliliters or cubic centimeters. There we go. That's much better. Okay, use the same method to find the volume of the marble. This time we're going to use the 25 milliliter graduated cylinder. I do think I want the pipette. I am going to fill this up with some water, and then I can add the marble. Okay. So I want to get a little bit more water. There we go. I don't need the pipette. I've started out at 15. I'm going to add the marble. It rose up to, remember, the medium increments were 1. And I would say that that meniscus is reading up to the 16 milliliter mark. So 15, 16. If I take 16 and I minus out 15, I am left with 1 milliliter. The marble, but again, it is a solid object, so it's cubic centimeters. Describe what we did to find the volume of the marble. I'll let you add on there what you did to find the volume of the marble. And then when measuring the volume of the marble, why was it better to use the 25 milliliter graduated cylinder rather than the larger 100 milliliter graduated cylinder? Okay, and maybe you can discuss this with a partner.